Hello guys, this is teacher Victor. This is Geography Form 1. This is syllabus coverage. As I said, this channel is majorly to help students, KCSE students or parents who wants to do KCSE to be able to get KCSE easier and pass. So I have KCSE past revision questions where I teach and give answers to the past KCSE questions. You can check at them, but if you want to start your learning process, learning journey to be able to do KCSE, kindly subscribe to my channel. I teach four subjects. That is mathematics, geography, business, so kindly feel free to join my classes. So this is Geography Form 1. When you join Form 1, you will be introduced to what geography is. You will be told to define what geography is, and all these things I have decided to make this soft copy a very easy way to make you understand what you will be doing by the end of this. The questions will always come from what I have prepared before you. So let's start. Introduction to geography. You will be told to define what geography is. So what is geography? Geography is the scientific study of the earth as a home of man. So geography is the scientific study of the earth as a home of man. Then somebody can also define geography as the study of interrelationship on natural and human phenomena on the earth's surface. So in exam, you will be told to define what geography is. That is going to be the very first question in your secondary school when you will be introduced to geography. Then you'll be told to define what is environment. So environment is just the surrounding. Environment is just the surrounding. All external conditions surrounding an organism which has an influence over its behavior. So environment is just the surrounding. Then environment can be divided into two. We have physical environment and we have human environment. So what is physical environment? Physical environment, natural physical conditions of weather, climate, vegetation, animals, soils, landforms, and drainage. So those are the physical environment. So natural physical conditions of weather, climate, vegetation, animal, soil, landforms, and drainage. Then what are human environment? What is human environment? Human environment is composed of human activities such as farming, forestry, mining, tourism, settlement, transportation, trade, and industry. So that is human environment. Then again, we will move further to discuss the branches of geography. In exam, you will be told to explain or state three branches of geography. So branches of geography, we have physical geography as the first one. So what is physical geography? Deals with the study of natural physical environment of humankind. So the areas covered under physical geography, we have geology. So what is geology? Is the study of the origin, structure, and composition of the earth. It includes the study of rocks. So geology is the study of origin, structure, and composition of the earth. And we have also said it includes the study of rocks. Then you have geomorphology. What is geomorphology? So this is the study of internal and external landforming processes and landforms. So this is the study of internal and external landforming processes and landforms. So that is geomorphology. Then what is climatology? Climatology, just from the name, is the study of climate and weather. What is pedology? This is the study of soils. What is biogeography? It is the study of soils, vegetation, and animals. What is hydrology? It's the study of water bodies. Then we have spatial geography, is the study of space. So that is the first branch of geography. So we have talked about physical geography. Number 2, we have human and economic geography. So human and economic geography. So what is studied under human and economic geography? It is the study of people and their activities on the Earth's surface. It's the study of people and their activities on the Earth's surface. So what areas are covered under this human and economic activities? So we have mining, forestry, agriculture, fishing, wildlife, and tourism. You have industry, and you have energy. So that is the second one. Then the last one is practical geography. Number 3, practical geography. So what is practical geography? It is a smaller branch which equips the learner with the practical skills that enhance their understanding and interpretation of human and physical geographical information. So that is practical geography. It is a branch which equips the learner with the practical skills that enhance their understanding and interpretation of human and physical geographical information. So what are the areas under practical geography? We have statistical methods, we have map work, we have field work, we have photograph work. So map work is a very important concept you're supposed to know as a student. All the 4 are very important. Map work is always in paper 1. Once you will start doing paper 1 and paper 2 exams, map work, field work, those are compulsory topics that will be there. Statistical methods, photograph work, those are things that you are going to do in your exams. They will be there in paper 1 and paper 2. Photograph work, statistical methods, map work, field work. Question 6 in paper 1 is always map work, which is always combined with field work. Then statistical methods is also another one which is always there in paper 2. Also sometimes it's also set in paper 1. Photograph work is also there in paper 2. So that these concepts are very important. You're supposed to understand them. The next thing you're going to look at is what are the importance of studying geography? What are the importance of studying geography? So what are the importance of studying geography? Why do people study geography? Why do people study geography? The first one, facilitates good relationship among nations by studying geography of other regions of the world. Facilitate good relationship among the nations by studying geography of other regions of the world. The next one, it is a career subject. It is a career subject in that it enables one to go for advanced studies in specialized fields, e.g. we have geography teacher, we have meteorologists, we have surveying. So it is a career subject. The next one is it enables us to appreciate other people's way of life by learning economic activities of different communities within our country and other parts of the world. Enables us to appreciate other people's way of life by learning economic activities of different communities within our country and other parts of the world. So geography enables us to appreciate how people live by simply learning the economic activities of different communities within our country and the world. The next one, is it enables us to conserve our environment when we learn negative and positive effects of human activities on the environment. So geography enables us to conserve our environment. As you will be going through, you will see the negative and positive effects of human activities on the environment. So through this, you will be able to conserve our environment. Number 5 enables us to conserve our resources when we learn wise use of resources in conservation and management of resources, e.g. wildlife, forest, and energy. We'll be seeing those as we move forward. Then the last one, number 6, it incorporates virtues of cooperation and patience as we work in groups. Most of the time when you're doing geography, most of the time you will be working in groups, especially for map work, field work, photographs, statisticals. So it keeps you with virtues of cooperation and patience as you work in groups. Number 7 makes us to appreciate manual work as we are involved in practical geography which may lead to self-employment. So makes us appreciate manual work as we are involved in practical geography which may lead to self-employment. Then the last one, promotion of industry such as tourism by guiding tourists to places of interest by using maps, calculations of distances, etc. So what is the next thing you're going to talk about? How is geography related to other subjects? How is geography related to mathematics? Why do you need mathematics to study geography? Or why do you study geography and also do mathematics? So mathematics equips mathematical techniques are used in drawing graphs and pie charts, and mathematical formula are used in geography to calculate distances, areas, population densities. So mathematical techniques are very important. We'll be drawing graphs, drawing pie charts. We'll be using mathematical formulas to calculate distances, areas, population densities, temperatures. So mathematics is very important when studying geography. Then why do you study history? Why do you need history when studying geography? History uses geographical tools like maps, charts, and graphs to show where the past events took place. So history uses geographical tools like maps, charts, graphs to show where past events took place. From the definition of history, history is the account of past events. Biology. Why do you need biology when you are doing geography? So geography explains the distribution of organisms and factors influencing their distribution on the Earth's surface. The next one is physics. Why do you need physics while doing geography? Geography uses physics principles and formula to calculate and describe aspects such as magnetic fields, gravity, vibrations of the earth. So that's why we need physics. Why do you need chemistry? Chemistry is very important when you're doing geography. Geography applies chemistry in studying chemical composition and chemical changes which takes place in the soils and rocks. As we are going to see as we move forward, there's a topic called rocks in Form 1 towards the end. So rocks have got chemical composition and we also have chemical changes that takes place in the soil. So that's why we need chemistry while doing geography. Agriculture. Geography studies farming systems, their distribution, and factors affecting farming activities. So that's why we need agriculture. Then you have meteorologies. Geography uses meteorological information in the study of weather and in classifying climatic regions and mapping them. Then you have geology. This is the study of rocks. So those are some of the subjects that are related to geography. Let's move to the next topic, which is the Earth and the solar system. The Earth and the solar system. So solar system is the group of heavenly bodies comprising the sun and the 9 planets. So solar system is the group of heavenly bodies comprising the sun and the 9 planets. The origin of the solar system. So we have the theories of the origin of the solar system. So we are going to talk about the theories of the origin of the solar system. What is a theory? A theory is a set of reasoned ideas intended to explain facts or events. A theory is a set of reasoned ideas intended to explain facts or events. You have passing star theory. Passing star theory. So, passing star theory, a star with a greater gravitational pull passed near the sun. It attracted large quantities of gaseous materials from the sun. The materials split, cooled, and condensed to form planets. The planets were set in orbit by the passing star. So that is passing star theory. A very straightforward. I have simplified this document so that it enables you to understand what is happening. You go and do your KCSE exams, pass, then do the course you want. We have weaknesses of passing star theory. So it does not explain the origin of the sun and the star. It does not explain the origin of the sun and the star. Minimal chance of a star approaching another. There is minimal chance of a star approaching another. Then you have materials would disperse. Materials would disperse than condense. So those are the weaknesses of passing star theory. Another theory is collision theory. Collision theory. So let's explain collision theory. A star with a greater gravitational pull passed near the sun. It attracted large quantities of gaseous materials. The materials split into portions. Large portions collided with smaller ones and swept them to form planets. So that is the collision theory. That is a collision theory. A weakness of a collision theory. The same weaknesses we have for passing star theory are the same weaknesses we have for collision theory. So these are the weaknesses we have for passing star theory. They are the same for collision theory. The next one is nebula cloud theory. Nebula cloud theory. So here is supposed to be nebula cloud theory. Nebula cloud theory. So what is nebula cloud theory? So let's explain. There was a slowly rotating cloud of dust and gases called nebula. It cooled and began to contract. It cooled and began to contract, not to contact, to contract. Rotation speed increased and successfully rings of gaseous materials were formed. The rings condensed to form planets. The rings condensed to form planets. The central gaseous material remained as the sun. So that is nebula cloud theory. Evidence. Rotation and revolution of planets in anticlockwise direction is an evidence of nebula cloud theory. Then here, weaknesses of Nebula cloud theory are not explained. Another one we have is supernova or explosion theory. Supernova or explosion theory. There was a violent explosion of a star. A cloud of dust, which is nebula, remained from the star. There was fast movement of clouds due to the force of explosion. Rotation speed increased due to gravitational attraction. The cloud flattened into a disk. Then the matter began to accumulate. The matter began to accumulate towards the center to form protosun, which later began to shine. The rest of the cloud collapsed to form planets. So that is explosion theory or supernova theory. Weaknesses of this particular theory are: does not explain the origin of the star. Also, they does not explain the cause of explosion. They does not explain the cause of explosion. So those are the theories. These are the theories of the solar system. In exam, you can be told to explain theories for the formation of the solar system. There are four. We have talked about explosion theory, also called supernova. We have talked about nebula cloud theory. We have also talked of collision theory. Then we have passing star theory. Those are the theories of that. So we have what are the compositions of the solar system? Compositions of the solar system. So the first one is the sun. The sun. It is the center of the universe. Sun is the center of the universe. Characteristics of the sun. It is a star. What is a star? A star is unevenly possessing its own light, which it transmits. Then you have nebula or galaxy. Is a cluster of stars. Cluster of stars is called nebula or galaxy. The Earth is in a galaxy called the Milky Way. The Earth is in a galaxy called Milky Way. The Milky Way. The Milky Way. It is made up of very hot gases, mainly hydrogen and helium, has a diameter of 1,392,000 kilometers, surrounded by a layer of gas which has boiled from its surface, which is called corona, rotates on its own axis in anti-clockwise direction, has gravitational pull which holds all the planets in an orbit. What is an orbit? An orbit is a path which a planet or a satellite follows around a planet. It is a path which a planet or a satellite follows around a star or a planet. Then temperature at its center is 15. So the temperatures are very high. Then radiates solar energy, which is very important to all forms of life on the earth. So that is all about the sun. That is all about the sun. That is all about the sun. We have talked about characteristics. These are the characteristics we have talked about. The planets. Remember, we are talking about the composition of the solar system. We are talking about the composition of the solar system. Number two, we are going to talk about the planets. Planets are large, spherical, celestial or heavenly bodies in space. There are 9 planets in our solar system. What are the characteristics of planets? They are spherical in shape, don't have their own light but reflect it from the sun, revolve around the sun in anti-clockwise direction, have their own force of gravity, only one is known to support life. Only one planet is known to support life. So we are going to talk about these planets one by one. We have the first one is Mercury, near to the Sun. It is 58 kilometers from the Sun, has no satellites, takes approximately 88 Earth days to revolve around the Sun. Number 2 is Venus. It is the second planet from the Sun. It is 108 kilometers from the Sun. One of the brightest planets, can be seen clearly with naked eyes. Takes approximately 225 Earth days to revolve around the Sun. Slightly smaller than the Earth, has no satellites. Together with Earth, they are called twin planets due to having many similarities. So Venus and Earth are called twin planets. Why? Because they have many similarities. Earth as the second planet, as the third planet. So Earth is the third planet from the Sun. The Earth and the heavenly bodies make the universe. The only planet that supports life, the home of man, approximately 149 kilometers from the Sun, takes 365.5 days to revolve around the Sun, as one satellite, that is Moon. Mars, also called the red planet because it is observed through a telescope. It appears reddish. It is the fourth from the Sun, slightly smaller than the Earth, approximately 228 kilometers from the Sun, takes 687 Earth days to revolve around the Sun. It is between Mars and Jupiter. Between Mars and Jupiter, there are small celestial bodies called planetoids. So celestial bodies between Mars and Jupiter are called what? Planetoids. Then it has no satellites. Let's move to Jupiter. It is the fifth from the Sun, approximately 778 kilometers from the Sun, largest in the universe, rotates on its own axis at a very fast speed. Has flattened poles due to its speed of rotation. Has very thick layers of ice on its surface. Takes 12 Earth years to revolve around the Sun. Has 16 satellites. Saturn, it is the sixth from the Sun, second largest planet, approximately 1,427 kilometers from the Sun. It takes 29.5 Earth years to revolve around the Sun. Has a ring around it. Has 18 satellites. Saturn has a ring around it. We have Uranus, seventh from the Sun, about 4 times bigger than the Earth, approximately 2,870 kilometers from the Sun, also rotates very fast, also has a flattened poles due to fast speed of rotation, appears greenish for being surrounded by methane gas, has 8 satellites, takes 84 years to revolve around the Sun. Then you have Neptune, one of the farthest from the Sun, 8th from the Sun, approximately 4,497 kilometers from the Sun, has satellites, takes 165 years to revolve around the Sun. Very similar in size, color, and characters in Uranus. The last one is Pluto. So Pluto is the ninth one from the Sun, farthest from the Sun, the smallest from the Sun, 1/6 of the Earth, then approximately 5,900 kilometers from the Sun, takes 248 years to revolve around the Sun. As one satellite, very little is known about it. Other celestial bodies. We have natural satellites. Any natural heavenly body that orbits around a planet, e.g., we have moon of the Sun, moon of the Earth, Triton for the Saturn, and Triton for Neptune. We have asteroids, or you can talk of planetoids, also known as minor planets, are small fragments of rocks left going around the Sun when the solar system was formed, found between Mars and Jupiter, are 1,500 in number. They sometimes collide with each other due to Jupiter's gravitational pull, causing them to move in erratic orbits. Then you have comets. Comets, heavenly bodies which appear to have head and long tail, made of ice, dust, and frozen gas. The head is made of many particles of dust, rock, and frozen gases. The tail is made of gases and points away from the Sun, move around the Sun in extremely long and oval orbits. Their orbits cross the Earth's orbit, e.g., early comets, which appears after 76 years. Then you have meteoroids. A small heavenly body which strays from its orbit in the solar system and enters the Earth's atmosphere at a very high speed. Then you have meteors. A meteoroid which is burning out due to friction after entering the Earth's atmosphere. Then you have meteoroids. You have meteorites, remains of meteoroids which have reached the Earth's surface incompletely burnt up meteoroids. They are rich in iron. Then we have the moon. A natural satellite receives its light from the Sun and reflects it on the Earth, revolves around the Earth, takes 29.5 days to complete one revolution around the Earth. Its orbit is almost circular. As it revolves around the Sun, it appears in various shapes ranging from crescent, new moon, half moon, Gibion's moon, and full moon. Has a gravitational pull which causes the rising and falling of the ocean levels. As the moon orbits around the Earth, it creates an event called eclipse. So what is eclipse? Eclipse is a phenomenon occurring when the rays of the Sun are blocked from reaching the Earth or the moon. You have the solar or sun eclipse. So you can see you have solar eclipse and lunar eclipse in the diagram. So in the solar eclipse, moon is between. In the lunar eclipse, Earth is between the Sun and the Moon. In lunar eclipse, in solar eclipse, Moon is between the Sun and the Earth. Kindly note that. So this is the diagram. The Moon comes between the Earth and the Sun. This is now in the solar eclipse or the Sun eclipse. In the solar eclipse, the Moon comes between the Earth and the Sun. The Moon's shadow is cast on the Earth. The Sun appears to be covered by a darkness. Then you have lunar eclipse or moon eclipse. The Earth comes between the Moon and the Sun. The Earth's shadow is cast on the Moon. then the moon appears to be covered by darkness. The origin of the earth, the origin of the earth, the origin of the earth. A star with a greater gravitational pull passed near the sun. It attracted large quantities of gaseous materials from the sun. The materials split, cooled, and condensed. Heavier materials collected at the center to form the core. Less dense materials collected around the core to form the mantle. The lightest materials formed the crust. So we have the shape of the earth. The shape of the earth is assumed to be spherical. So this is a very important question. Proofs or evidence that the earth is spherical. So this is a very important thing you're supposed to know. Proofs that shows proofs or evidence that the earth is spherical. Very important, very common question. The first one, if one moves towards the east in a straight line, he will end up where he started. If one moves towards the east in a straight line, he will end up where he started. That is circumnavigation. Number 2, satellite photographs taken from the space show that the earth is like a sphere. Satellite photographs taken from the space show that the earth is like a sphere. That is the second one. Places, number 3, places in the east see the sun earlier than those in the west. Places in the east see the sun earlier than those in the west. That is another one. Number 4, when a ship is approaching the smoke, is seen first, then the mast, and finally the whole ship. When a ship is approaching, the smoke is seen first, then the mast, and finally the whole ship. Number 5, talk about all the planets are spherical. From what we said in the solar components of the solar system or composition of the solar system, we say that all planets are spherical, and remember Earth is one of them, so is also spherical. So we say all the planets are spherical, so the Earth being one of them is also spherical. Number 6, during the moon eclipse, the Earth casts a spherical shadow on the moon. During the moon eclipse, we have just discussed the types of eclipse. You have solar eclipse, which is also called sun eclipse. Then you have lunar eclipse, which is also called moon eclipse. So during the moon eclipse, the earth casts a spherical shadow on the moon. Then number 7, the earth's horizon appears curved when observed from a very high point, like a tower. The earth's horizon appears curved when observed from a very high point, like a tower. So those are the proofs that shows that the earth is spherical. This is very important. It is always there. It can be set in case you see it has been set. People have failed, people ignore this. So this is very important. Proofs or evidence that the earth is spherical. So the size of the earth, so you have equatorial diameter of 12,756, equatorial circumference of 40,085 kilometers. Polar diameter we have 39,995 kilometers. Surface area of the earth is 5.0 times 10 raised to power 6 kilometers square. Then water surface is 73%. The movement of the earth. There are two type, there are two movements of the earth. There are two movements of the earth. Don't forget that. We have rotation of the earth on its axis. We have revolution of the earth around the sun. So let's start with the rotation of the earth. Rotation of the earth. So the first one, we say rotation of the earth is the movement of the earth on its own axis. Rotation of the earth is the movement of earth on its own axis. Somebody can say it is an imaginary line through which the center from North Pole to South Pole. So it is the movement of the earth on its own axis. Rotates 360 degrees. It takes 24 hours to complete one rotation. Rotates in an anti-clockwise direction, west to east. So that is rotation of the earth. It rotates through 360 degrees. It takes 24 hours to complete one rotation. Rotates in anti-clockwise direction, west to east. So what are the effects of rotation of the earth? Effects of rotation of the earth. Effects of rotation of the earth. Effects of rotation of the earth. The first one, it creates day and night, because at any one time one side of the earth faces the sun, which is day, and the other remains in darkness, that is night. So it creates day and night. That is an effect of rotation. Very important, being set in exam, state 3 effects of rotation. Number 2, you are told, so number 2 causes deflection of winds and ocean currents in the north hemisphere to the left and in the south hemisphere to the right. Causes deflation of winds and ocean currents. So it causes deflation of winds and ocean currents. The next one, it causes rising and falling of ocean tides. Rotation causes rising and falling of ocean tides. Number 4, it causes different time. It causes time difference between longitudes. It causes time difference between longitudes. It causes time difference between longitudes. As you can see, it takes 1 hour to go through 15 degrees. Therefore, it takes 4 minutes to go through 1 degree. We have calculations of the local time. Calculations of the local time. The time recorded in a place within the same longitude. So what is a longitude? A longitude is an imaginary line running from north to south, which shows how far east or west a place is from the prime meridian. A longitude is an imaginary line running from north to south, which shows how far east or west a place is from the prime meridian. So what is Greenwich meridian? It is the point of reference when calculating time. So Greenwich meridian, it is the point of reference when calculating time. So time is gained to the east and lost to the west. Very important, time is gained to the east and lost to the west. Time is gained to the east and lost on the west. So we have examples of such calculations. We are told, suppose the time at GWM is 12 noon. What is the local time at Watamu 40 degrees east? So the very first thing you're supposed to know, time is gained to the east and lost to the west. And you have said it takes 1 hour to go 15 degrees, which you have also said it takes 4 minutes to go through 1 degree. So here you have 40 degrees. So you say if 1 degree is equals to 4 minutes, what about 40 degrees? is equals to what? So you're going to have 40 times 4, you're going to have 160 minutes. If you convert 160 minutes into hours, you're going to have 2 hours 40 minutes. Then you have said to the east a time is gained, to the east time is gained, to the west time is lost. So this is to the east. So what are we going to do? What are we going to do now? So we are simply going to add. We are simply going to add 2 hours 40 minutes to 12 noon. We are going to have 1440 hours. 1440 hours in 24 hours. In 24 hours, or you can in 12 hours system, you are going to have 2:40 p.m. Example 2. At Dar es Salaam, 40 degrees east, time is 12 p.m. What is the time at Ikuda, 40 degrees east? Is it 40 or 20? So here is supposed to be 20. Sorry for that. So this is 20. So this is 20. So we are simply going to add this. We are going to have 60 degrees. 60 multiplied by 4. We are going to have 240 degrees. Then it is 4 hours. Equator is behind because it is to the west. So we are going to subtract that. We're going to have calculation of the longitude. Calculation of the longitude. So it is not in order for me to dictate calculations. Calculations needs to be done practically as you ask for questions. So standard time and zones. Standard time is time recorded by countries within the same time zone. Standard time was come up with due to confusion resulting from the time changing at every longitude. The world has 24 time zones. The international dateline. It is the 180 degrees longitude. Effects of international dateline, very important. Effects of international dateline, very important. Effects of crossing international dateline, very important. So these are the effects. One gains time when it crosses it from west to east and has to adjust the clock ahead by 24 hours. One gains time when it crosses it from west to the east and has to adjust the clock ahead by 24 hours. One loses time when it crosses it to the east to west and has to adjust the clock backwards by 24 hours. So you must know these effects of international dateline. This one is very important. This one is very important. A day is lost. A day is lost. A day is lost to the west. A day is gained to the east. That is the summary of what I have said there. You have revolution of the earth. Revolution of the earth. So it is the movement of the earth in its own orbit around the sun. It is anti-clockwise. The orbit of the earth revolution is elliptical. It takes 365 and a quarter days in a year, or 366 days in a leap year. This in a leap year happens after every 4 years. The sun moves from the Tropic of Cancer to the equator and then towards the Tropic of Capricorn and back to the Tropic of Cancer. 21st March and 23rd September are called equinoxes. Kindly remember this. 21st March, 23rd September are called equinoxes because the length of day and night is equal. Dates of equinox. Kindly remember this, very important. 21st of March, 23rd of September are called equinoxes. Why? Because the length of the day and night are equal. 21st June is summer solstice because it is summer in the north hemisphere. 22nd of December is called winter solstice because it is winter in the south hemisphere. Kindly remember this, they are being set in exams. It can either be mock, post-mock, pre-mock, KCSE exams. Very important. Very important. So you have revolution of the earth. So you can see you have 23rd March, 22nd, 23rd September, equinoxes, 22nd December, Capricorn, then you have 21st June, you have summer. What are the effects of revolution of the earth? Effects of revolution of the earth. It causes four seasons, summer, autumn, winter, and spring due to the movement of overhead sun causing changes in the heat belt. Another one causes variation of day and night lengths due to the Earth's axis being inclined to the path of the revolution at an angle of 60 degrees. Causes changes in the attitude of the midday sun due to the Earth's orbit being elliptical. Causes lunar eclipse due to revolution bringing the Earth in line with the sun and the moon. So we have four effects of revolution. Remember them. Causes four seasons, causes variation of day and night, causes changes in the attitude of the midday, then causes lunar eclipse. So that is the first lesson we have done. So from there we are going to move to the second lesson, which is the structure of the earth. I don't want to keep this video so long, so this is just 1 hour. We are done. So let's meet in the next class. The structure of the earth. The structure of the earth. This is Teacher Victor Onyango. Kindly subscribe, share, comment. You can as well as give any complaint in the comment section or suggestion. I will react to them. Thank you. Have a nice time.